Your learning target for this lesson is I can solve problems that involve vertical angles, corresponding angles, and alternate interior angles. And we're given a diagram, and we're told that in this diagram, lines S and T are parallel. The measure of angle 2 is shown as 5x minus 30 degrees. The measure of angle 6 is 3x plus 10 degrees. And our job is to determine the measure of each angle formed by lines S and T and transversal R. So the first thing that we need to do is figure out what is the value of x. And what we know from parallel lines and the background about parallel lines is when you have a pair of parallel lines and a transversal that passes through, you end up getting 4 congruent acute angles in this case, and 4 congruent obtuse angles in this case. Now, the acute angles are those that are less than 90 degrees, and I'm going to point out 2 of them right here. These 2 angles, angle 2 and angle 6, are called corresponding angles because they are in the same corresponding position in relation to the parallel lines. They're both above the parallel lines, and they're both to the right of the transversal. So we call these corresponding angles. And we know that corresponding angles are congruent when it comes to these parallel lines with the transversal. Since we are told that the lines are parallel, we know that these angles have the same measure. So I can set their measures equal. Now I'm going to solve for x by subtracting to both sides of the equal sign, subtracting 3x from both sides of the equal sign. And when I do that, I get 2x minus 30 is equal to 10. Now I'm going to add 30 to both sides of the equal sign, and I get 2x equals 40. Let's divide both sides by 2, and I get that x is equal to 20. That does not mean the measure of angle 2 is 20 degrees. It means that x in the diagram is equal to 20 degrees. Therefore, the measure of angle 2, I'm going to substitute 20 in place of x, is 5 times 20 minus 30 degrees. I'm now going to apply order of operations, 100 minus 30, or 70 degrees. So I know that angle 2's measure is 70 degrees. And because angle 2 and angle 6 are congruent, I also know that angle 6 measures 70 degrees. Now I could solve angle 6 by plugging 20 in place of x here. And so just to prove that it will definitely equal 70 degrees, I'm going to do 3 times 20, right, because that's what the expression shows, plus 10. That's 60 plus 10, which is indeed 70 degrees. Okay, so there are other angles that also equal 70 degrees in this diagram. You will notice across from angle 6 is angle 7. These angles are called vertical angles. They are directly across from each other. And whether or not we had parallel lines, if we just had these 2 lines here, any angles that are directly across from each other will be congruent. Again, these are called vertical angles. So for that reason, the measure of angle 7 is also 70 degrees. There's one other 70-degree angle in this diagram, and that is angle 3. And angle 3 is also 70 degrees. So now what I'd like to point out before we go further is these 2 angles here, angle 3 and angle 6, they have a special designation. Angle 3 and angle 6 are called alternate interior angles. And the reason why they're called alternate interior angles, first of all, they're inside the parallel lines. That's why they're interior angles. And they're alternating interior angles because one is on the left side and up high of the transversal. The other is on the low side and to the right of the transversal. So they're on alternating sides of the transversal. Another pair of alternate interior angles would be 4 and 5. these two angles, although they're obtuse, they would also be congruent. All right, so earlier we said that when you have a pair of parallel lines and a transversal, you end up with, in this case, 4 acute congruent angles, which we've shown. We're also going to have 4 obtuse congruent angles. And let's show in blue the measure of angle 1. If the measure of angle 2 is 70 degrees, then I'm claiming that the measure of angle 1 is 110 degrees. Why is that? Okay, so if angle 2 was 70, then angle 1 must be 110, because you see these angles form what's called a linear pair. They are next to each other on a straight line, and they add together to equal 180 degrees. So to get the measure of angle 1, I simply subtracted 180 minus 70 to get 110 degrees for the measure of angle 1. So you will write that the measure of angle 1 up here is also 110 degrees. All of the other obtuse angles will also equal 110 degrees. But we can show why here. Angle 4 is a vertical angle with angle 1, so they are congruent. And we said that angle 4 and angle 5 are what's called alternate interior angles. Therefore, angle 5 will also be 110 degrees. Finally, we might as well bring up one more pair of special angles here, and that would be angle 1 and angle 8. Notice these are exterior angles, and they are alternate exterior angles. Because they're both outside the parallel lines, angles 1 and angle 8 are, and they're on alternating spots of the transversal. One is on the left side, one is on the right side of the transversal. One is high and one is low. So I guess what we want to think about when it comes to parallel lines and a transversal is special pairs of angles will be formed. And in most cases, assuming you don't have a transversal that's perpendicular to these parallel lines, in most cases you will have 4 acute angles, which I've shown in green. We will have 4 obtuse angles, which I've shown in blue. And turns out the obtuse and the acute angles will always be equal to 180 degrees when you add them together. Now, how I got the measure of my first angle, remember, was I noted, oh, these are 2 acute angles, therefore they must be equal. I went ahead and I used what I know about solving equations. I solved for x. Once I got my 20 for x, I plugged 20 in place of x here. 5 times 20 is 100. 100 minus 30 is 70. And I just completed the rest of the diagram and the rest of the missing angles from there.